Hi there, welcome to another Maths A lesson. Today we're going to talk about the surface area of 3D shapes. Now before we start doing surface area, we just need to understand the names of 3D shapes and how they are classified. So let's firstly talk about prisms. Now, prisms have two bases which are parallel and have the same shape. And they also have a constant cross-section parallel to the base of the prism. And you're probably thinking, what is all that? Well, firstly, let's draw a shape which we're going to call the base. So let's say this is the base of our prism. And let's say this is a square with 4 equal sides. Now what happens is at the other end of this 3D shape, it's going to have the exact same shape. Actually, I'm just going to make a copy of that so we know that it's exact. So I'm just going to copy this. So you can see that I have copied the shape and paste it at the top, and this shape is going to be parallel to our base, and all the ends will be joined by a straight line. All the corners will be joined by a straight line. So this is what we call a prism. And so the two bases, the top and the bottom, they're both our bases and they're parallel and they have the same shape. A constant cross section parallel to the base of the prism. Now what that means is if you were going to cut this shape up somewhere along the middle, so if we cut up this shape, let's say we cut it here. Okay, and whatever cross section that you can see as a result of our cut is going to be the same no matter where you cut it. So you can cut it over here with your chainsaw or whatever it is you're going to use to cut the shape up. It'll have the same cross section no matter where you cut it. Okay, so other prisms, it could be rectangular base or it could be a circular base, which we also call a cylinder in this case. So that's a cylinder there, and that's a rectangular prism, and so on. Okay, now we're going to talk about pyramids, which is a shape that you are no doubt familiar with if you have seen pictures of pyramids in Egypt. So basically we still have a base, and let's do our good old square base. So all lengths are the same, and what we're gonna have is a point somewhere on the top, and we're gonna join all 4 corners of the shape to the point. Oops. And this is what we call a pyramid. That circle a bit bigger. Now that's a pretty badly drawn pyramid, but you can get what I'm saying. And so that's called a square base pyramid, and you can see that the cross section reduces in size closer to the point. So if we cut up this shape, let's say at the top somewhere here, let's say we cut that up, the cross section will be a lot smaller than if we cut it up towards the end of our shape, towards the bottom of our shape. Actually, let me just draw that horizontally. So depends on where you cut it up, the cross section will be different in size. Now you can also have a circle as the base. If your base is a circular shape, then we also call that a cone. So that's a square base pyramid, and that's a cone. You can also have a triangle as a base. So if that's your base and you have a pyramid joined like that, then this is a triangle base pyramid. Hopefully you will be able to draw better looking shapes. So basically they're the two main, the last one is spheres. So a sphere is just a fancy name for a ball, so you should be really familiar with that. And what you need to notice about a sphere is that there are no flat faces, right? So a sphere, well, really you can draw a circle and maybe color it differently. So that's a ball, a 3D ball. I'll leave it up to your imagination. So that's a sphere, and obviously if you have half a sphere, it might be a bit easier to draw. If you have half a sphere like that, then that's called a hemisphere. H, hemisphere, it's half a sphere. And you notice that if you cut up the sphere somewhere, if you cut it up, then you get a circular cross section. So this part here is a circle. Okay, so once we have defined all the 3D shapes, we can now talk about the surface area of the 3D shapes. So the surface area is the total area of all exposed faces. Now I'm just going to draw a cube and then I'll show you what I mean. Now this is a cube where all faces are equal, have the same size, and all the side lengths are equal, and the faces have the same area, and so on. So if we unwrap this cube into what we call a net, then what happens is if you were going to unwrap this, it becomes something like this. Sorry about the drawing, but all sides are equal again, and so basically a net is what you do, what happens when you unwrap a 3D shape. So the total area of all exposed faces. So basically we want to add together all of these areas. Let's call them areas 1, 2, 3, 4, 5, 6. Alright, so the total surface area, which we're going to call TSA, total surface area is going to be area of 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now you can imagine for a cube where all the faces have the same area, and remember a cube is a prism as well. All you have to do is find the area of one of them and times by 6. So let's say I make each side length 6 centimeters. Okay, so area of number 1 is just going to be 6 times 6. Alright, because it's area of a square is side times side, so 6 times 6, and there are six sides, so all we're just gonna do, we're gonna times by 6 again, so that becomes 36 times 6, that's 216 centimeters squared. Now we're gonna do centimeters cubed later on for volume, but right now we're still just finding the area of shapes, so we'll keep going with centimeters squared. So that's how you find the total surface area of a cube. So the formula is the TSA of cube, TSA for cubes equals side squared times 6, right? Because there's always 6 faces. So here I have drawn a rectangular prism, and we're going to find the TSA of a rectangular prism, total surface area, and you can see that there are 3 different areas for the rectangular prism. There's area 1, area 2, and area 3. These are 3 different rectangles, and there are also 3 faces that we can't see on the other side of this shape, right? So after we find the area of these 3 shapes, we're then going to multiply by 2 to give us the total surface area of a rectangular prism. Now so let me just label the sides. Let's say I have the length down this side and the width down this side and the height going up. So the total surface area will be the area of 1 plus the area of 2 plus the area of 3, all of them added together and then times by 2. So area of 1 is going to be the length, because this side is the length, times by the width, because this side is the width. So we got length times width, that's the area of 1, plus area of 2 is going to be length times height, and area of 3 is going to be width times height, and all of them added together and then multiply by 2. So really the short way of writing that is 2 bracket LW plus LH plus WH. Right, because if you remember a bit of algebra, when you write 2 alphabets next to each other, you don't have to write times. It just automatically means times. So let's assign some values to these variables. Let's say length is 10 centimeters, width is 6 centimeters, height is 2 centimeters. So putting them into the formula, I have 2 bracket 10 times 6 plus 10 times 2 plus 6 times 2. So put all that in the calculator. That's 60 plus 20 plus 12 times 2, which is 184 centimeters squared. So that's how you find the surface area, total surface area of a rectangular prism. Now the total surface area of a cylinder. Cylinder is a very interesting shape. If you unwrap the cylinder into its 2D form, which is a net, if you unwrap this, what happens is you have a very long rectangular shape which makes up the middle of the cylinder. So this rectangular shape is this part here, and then we have 2 circles at the top and at the bottom. Okay, so the rectangular shape, obviously we have the height of the cylinder going up, so that will be the same for the rectangular shape. We have the radius for the circle. So how do we find the length of the rectangle from here to here? What is the length across that way? Now, if you imagine this shape coming together into a cylinder, what happens is this length matches the circumference of the circle, otherwise they wouldn't fit together properly so well. So therefore all we have to do is find the circumference of the circle, and that will be the length of this rectangle. So the length is actually equal to 2 pi r, which is the formula for the circumference of a circle. So the TSA is therefore equal to the area of the 2 circles plus the area of rectangle. The area of the 2 circles is pi r squared times 2, right, because there's 2 of them, plus the area of the rectangle is 2 pi r times h, right, length times width for a rectangle. So written that that formula written in the short form will be 2 pi r squared plus 2 pi r h. Okay, so let's say we have a radius of 6 centimeters and a height of 8 centimeters. So then this will be 2 pi r, 2 pi times 6 squared plus 2 pi times 6 times 8. Put all that in the calculator. So we got 2 times pi times 6 times 6. That's 226.194. Plus we have 2 times pi times 6 times 8. That's 301.593. So add them together. 226.194 plus 301.593, 527.8 centimeters squared, rounded to 1 decimal place. Okay, so that is the surface area of a cylinder. And let's do a square-based pyramid.